and welcome to today's exciting COMP1511 lecture. So today we'll be looking at a new thing called unit testing, an old thing called arrays, and an old thing called functions. I hope did anybody meet somebody new at the start? No, you should swap where you're sitting and sit in different places and meet new people. Like, the friends you make at uni will maybe be your friends for life, all that sort of thing. Cool, so, a bit of a long list today, but it's hopefully all not actually too long. So, assignment 1 is out, and one of the things we're going to focus on today is the stuff that you need to know in order to do assignment 1. And so for that, we'll be looking at a thing called unit testing, which is testing that your code works. We'll hopefully look more at designing a solution to a problem. I'm going to look more about passing parameters into functions. I had a lot of questions about that after the lecture yesterday. And more on arrays. Cool, so some admin. Step 1, don't panic. We're sort of hitting the end of week 4. Things are getting a little bit stressful. I know a lot of people have sort of found the course has suddenly jumped and they've gone, oh my god, this is really hard. Shh. It's okay, don't panic, things will be okay. Lecture recording style guide. The weekly test from last week is due tonight. If you haven't done it, then please, please, please do it tonight. It's quite straightforward. If you can't solve question 1, if you've been in the lectures, then you will be able to solve question 1 like in your sleep, so that's fine. Assignment 1 is released, and don't forget about the help sessions. So let's jump right into the assignment. Is it going to load this time? Oh, man. Can you fix that? Do you know how to fix that? Okay. Cool, so you might remember yesterday I tried to show the link to the help sessions and it didn't load and I gave up, but it's loaded here. These are optional, but if you're confused, if you're behind in the course, if anything's going hard, shh. If things are tricky, you have questions, we have 1, 2, 3, 4, 5, 6 sessions each week with tutors. There's several fantastic tutors who'll be there, they can help you out. Answer your questions, so there's ones on Monday, Wednesday, Thursday, Friday, and Friday. Cool, so look at this on the course website under help sessions. If you're having difficulties, go to them, it'll be great. And now onto the assignment. This could probably go with some better margins. Is that font size readable? Is it too small for anybody? Cool. So, for this first assignment, how many of you have family that lives somewhere other than Sydney? So family in another city, another country? Okay, about half of you. So I do. My family are in New Zealand. I'm from New Zealand. You may or may not be able to tell. And I like to talk to my parents, right? I'm one of those crazy people who likes to talk to their parents. Your parents are great people. You may like them more in a couple of years' time. But I like to talk to my parents, right? And New Zealand's in a different time zone. And so I need to make sure that when I'm going to call them or message them, it's not going to be like 3 a.m. in their time, right? Because then they'd be woken up and they'd be really sad. Or sort of annoyed at me. Oh, Andrew, why are you calling me at 3 a.m.? I'm sleeping. So your task with the first assignment is to write a program that will work out what the local time is in your town. And by your town, I mean the town that we tell you to do. So that when you're phoning home to your hometown, you don't call too early or too late and wake your family. So to do this, you're going to write a function to calculate the local time in some town that we specify. And they'll be in Australia and New Zealand only because there are a lot of towns and a lot of time zones in the world. Limiting it to just these two countries, it's tricky enough as is. And you'll also be required to write some tests for your function. So we'll look at that in the second half as well. So I'm going to sort of quickly walk through the relevant parts of this. Please go home and read it tonight, or read it now if you're really bored of me talking, but definitely read this yourself. I'm just going to give you sort of like a high-level overview. So in this assignment, you'll be writing this function called getLocalTime. And that's given two main things as input. The town that you should convert it 2, and a date and time in UTC. So the town will be one of these ones from this list of 14 towns. So there's only 14. It's fine. You'll be writing some tests. It's fine. We'll also get to that. It's due on Sunday, the 8th of April, which I think is the end of the mid-sem break, which I think gives you 2.5 weeks or something. Anyway, so there's time zones, right? How many of you don't know what a time zone is? And I say the word time zone and you're thinking this is really confusing. I hope, okay, a couple of people are confused. So different countries are in different time zones, right? So it's currently 2:18 p.m. here, which means the sun is roughly, it's roughly sort of after halfway through the daylight hours. But in New Zealand, say, it'd be 4:18 p.m. So they're in a different time zone to us, even though like the point in the Earth's circuit around the sun it's the same in both places, right? Shh. They're in a different time zone, and so the local time for them is different to the local time for us. And because local time varies, computers need a way to be consistent. Like it's important that, for example, on the internet, if you post on Facebook and you post a comment and someone else posts a comment, it needs to know which order they go in, right? And so rather than using like the time on your computer, computers use a thing called UTC, which stands for Coordinated Universal Time, but in French. I'm not actually sure what the French is. Okay, it's just... Okay. To those of you who didn't hear that, one of the tutors said something that was kind of funny. Wasn't super funny, you didn't miss out. No offense. But UTC stands for Coordinated Universal Time, which is CUT, and so it's not written as cut because that'd be weird. Anyway, so this is a time in UTC is like a fixed point, and then the time zones are offset from that. So, for example, we're currently in Sydney, and we're during daylight savings, so we're in what's called Australian Eastern Daylight Time, which is UTC plus 11. So the current time in UTC time would be 14 minus 11 is 3:20 a.m., I think. And so if you wanted to work out the time in, I don't know, somewhere in America where their time zone was like UTC minus 3, you can work out the time for us in UTC and then subtract the minus 3 from their time. And so your task for this assignment is going to be to write a function that does this conversion for us. So we say, here's the UTC time, here's the city to convert it to, what time is this in that city? So you might be asked to convert the UTC time of Saturday, 24th of March, 6:30 a.m. 2018 to the local time in Sydney. So if Sydney is in UTC plus 11, what time would that be? What's 11 plus 6, 17? 5:30 p.m.? Cool. You only need to return the time, not the date, because like with the time zone changes, the date might change. That's fine, just the time. But a huge part of this is you're going to need to, you yourselves will need to go out and research time in Australia and New Zealand. So research how the time zones work, what the time zones are, how daylight saving works. So with daylight savings, I assume you're all aware of this, but we change our clocks, put them forward an hour at some point and back an hour at another point so that the time zone is shifted. So you will need to take into account things like daylight savings in your assignment. But you will have a lot of fun researching time zones. I had a lot of fun researching time zones. And a huge part of any coding task, lab exercises are very small in scope, but any sort of realistic coding task, assignment thing in the real world, a huge part of that is sort of exploring what you need to be doing, working out what you need to be doing and how to, all of the sort of strange edge cases and things that you don't understand and so on. And it's also important to have a precise understanding of time. So the idea behind this assignment is that the solution itself, the code itself, the things you need to write the code for this are if statements, functions, variables. That's it, right? So we covered if statements, variables in like week 1 or 2, functions in like week 2 or 3. Deliberately, the syntax required is very, very simple. So the challenge here shouldn't be what syntax to use. The challenge here is working out your approach to solving the problem. So trying to break down this problem into, I need to do sort of this step, this step, this step, that sort of thing. And one of the key things when doing things like this assignment, don't start coding straight away. If you do that, you just get horribly lost and confused. So think about it a lot, try and understand it. Do examples on pen and paper, draw diagrams, make some flow control diagrams. Those are quite helpful. If you have questions, you can ask them on the course forum. Don't try and sit down and solve the assignment all at once. I did that and I didn't succeed when I tried to write the answer to this originally. So you need to stop and think about it a bit. Allow at least 2 weeks. So if you're a new programmer, get started straight away. Have a lot of time to think about it, try and solve the problem, all of that sort of thing. If you're an experienced programmer, don't think, oh, I know what I'm doing, I can just sit down and solve it all in one session, the day before the due date. You can't. And even if you could, that would be bad. So lots of time, go at it slowly, everything is good. In terms of how we store the time, we store things as integers. So the towns are represented by the integers 0 to 13, but we have hash defines for them. Months 1 to 12, days 1 to 31. The times are the hours times 100 plus the minutes. So 6:45 a.m. is 6:45. 7:20 p.m. is 19:20. So 24-hour time. Midnight, the start of the day, is the integer 0. But not all of the integers in the range 0 to 20 through 59 are valid times. You can't have 15:67, 67 minutes past 3 p.m. It's not a valid time. And the year is always going to be 2018, you can assume that. Here is the code to start the assignment. It's still not found. That's okay, I'll fix that. I'll do that in a second. So again, read through all this in your own time. Also, to go over it again quickly, you're given the city, the month, day, and time in UTC, and you need to return the time in that local time. So this code that you're provided with to start with will get the time right for Sydney at the moment because it's daylight savings time, but you'll need to add a lot more interesting things to this. And it's also very important that you make your own functions. So don't try and do this all on the main function. This is sort of like your main function in this assignment. The get local time is the part that gets called when your code runs. So this is sort of like your main function. Was that a question or a stretch? The second, this one here? Is that the question? Cool, yeah. So we're assuming that we ignore the seconds part of the time, so just hours and minutes. The seconds part is irrelevant. So yes, make your own functions. Don't do this all in the one function, or I will be very sad. I will actually probably cry. I might not literally cry, but I will feel very sad in my heart. So cool. The second thing that you'll be doing, the other sort of main component, is to write these things called unit tests. We'll talk more shortly about what those actually mean. But this is basically a way of checking that your program works. So you're giving it a situation. For example, if we look at Sydney on its month, day, time. Yep. So on the March the 20th at midnight, that UTC time should be 11 a.m. in Sydney. Oh, look, it's written up there. Then this sort of thing, if we're looking at the 42nd month, it's not a valid month, so return invalid input and so on. Cool, more on that soon. We give you auto tests, but it doesn't actually test that your code is right. It just tests that you've sort of structured it, that it returns a value that's valid. Because a huge part of this is writing your own tests, working out the cases that you need to test to consider if things are right. This is a bunch of clarifications, assumptions. It's just saying don't use all these things that you can't use. Don't use printf, don't use scanf, don't use loops, don't use gotos, don't use switches, don't use, all you need, if statements, functions, variables, and then math, adding, subtracting, and all that. Again, individual assignment, don't cheat, blah, blah, blah. Submit as you go through. So this is another really important thing. Every time you make some progress, you should submit it using give. It's fine if it doesn't compile or if it fails the tests. We'll store like all of the copies of the code that you submit as you work on it in a thing called a Git repo. And all you need to know is that you get this web page to go to, and this will let you see all of the previous versions of your code. So we expect that you will, when you write any amount of code, commit it or submit it via give, it'll end up in this place. And then we also have a record of like, did you do it all on the last night before it was due? Hopefully you didn't. Worth 5% overall, 75% of the marks come from your function working, 15% come from your style, hand marking of the readability of the C, so don't write bad code. This is one of the times in the course where we will provide marks or deduct marks if your code is not written well. So we'll be assessing how easy it is for humans to read your code. 10% of the marks from the unit tests. Here's a rough thing. If it works on everything perfectly, beautiful, 100%. If it works on some inputs, you've added some unit tests, the code's sort of readable, you get like 55%. If you give someone else your code and they submit it, that's negative 70%. If you submit someone else's code, you get negative 70%. If you pay someone to do the work, like if you post on one of those sites where you can pay people to do things, to do your assignment, you fail the course, like 0 fail for the course. Very serious stuff, don't do that sort of thing. Late penalty, 2% per hour it's late, so don't submit late. Are there any questions so far about this quick ramble rush I've done through the assignment? Is that a thumbs up from the tutor saying that this page exists now? Refresh the page with the link. Aha, excellent. I'll chuck this into gedit so that it's got syntax highlighting. Maybe. Okay, excellent. So I'll just sort of run you briefly through the code. We give you hash defines. So when you're talking about the town Adelaide, you should use the words town Adelaide. You should not use the number 0. If you refer to the town Adelaide as the number 0, that is like semantically incorrect. By semantically incorrect, I mean maybe it'll compile and work, but it's not, it doesn't make sense to do it that way. So always use the hash defines. Compare if town is equal to town Darwin, for example. There are some New Zealand ones. Here are the time zone offsets. So we give you the time zone offsets. So for example, Australian Eastern Standard Time is UTC plus 10, but we don't tell you which cities are in that or when the daylight savings happen or anything. So these are the offsets that you'll need to use. If you make more hash defines, add them here. If you make more functions, when you make more functions, add their prototypes here. Don't touch this main function. It just helps you like debug your program, basically. You can tell it to call the unit tests or like tell it to manually test this time, you know, tell it Adelaide, 1 p.m. and so on, and then it'll tell you what the output is. So basically you can use this to test your code, just don't change it. And then here is the function that you'll be writing. You'll become very familiar with this soon. Add your functions here, so when you write more functions, put them here. And then writing your tests, think about sort of your overall strategy for writing the test. So what are you trying to achieve? What's the method you've taken? Write a comment about that here. And then for each of your tests, write a comment about it. So for example, this is doing this, this is doing this. You should write at least 40 more assert statements. That sounds like a lot. It's actually fine. Like do your birthday and your parents' birthday and your brother's birthday, your friend's birthday. Cool. Easy way to do 40. But think through different cases you should test and write tests for them. Cool. Are there any questions so far? Okay, and if you do have, question, yes. Yes, can I explain the late submission part, Clara? I can give it a shot. So I did just sort of skim over that. Basically, I don't know how it works in other subjects or faculties. I think their late penalties are not quite the same as this. But because you can submit these online, like, like the labs and stuff, rather than having a late penalty per day or per week, it's like per hour. So if you submit the assignment 1 hour late, it reduces the maximum mark that it can achieve by 2%. So if you submitted your assignment and it was, it scored 50% and you submitted it an hour late, the maximum mark it could get would be 98%, and so it doesn't affect your mark. And I'll say that again because this is a thing that we do that other people don't do. We reduce the cap, the maximum mark you can get. So if you submitted your assignment 10 hours late and you would have gotten the mark 74, you'll still get the mark 74. Submitting 10 hours late means the cap on your mark is going to be 90%. 80%, because I can do math. So if you were going to get a mark above 80, you'll get a mark of 80 now. And if you submit it 15 hours late, the cap would be 70%. So it would get 70%, not 74%. So try and get it finished on time. Do get it finished on time. If you haven't got it finished on time, still submit it because you still can get some marks for it. Cool. Does that answer your question, person with question? Cool. Are there any more questions? Okay. Shh. Now let's look at something new, and by new I mean I just talked about it existing. And so this is the requirements. All you need are if statements, functions, and asserts. No loops, no arrays, like all you need are these things. And so one of the things you have to do is to test your code using unit tests. And so the idea behind unit tests are it's a lot easier to test a small part of your code to see if it works than to test everything overall. And in this case, we are sort of testing everything overall. Your get, is it called get local time function? I've just completely mind blanked. Get local time, cool, yes. So you're basically writing a test that would test your get local time function to see whether it's given the right answer. And then for larger programs that you might write in the future, you'll write unit tests for sort of smaller subparts of that. And so the way that this works is we use a thing called assert. And asserting, or like an assertion, is basically saying this thing must be true. And if this thing is not true, then like the world is ending, so just quit the program, die, not okay. So for example, if we have int I equals 3, and then assert that I is equal to 3, is 3 equal to 3? Yes, no? Yes, cool. 3 is equal to 3. So this will happily move on with your program, this is fine. If we said int I equals 4, and then we had assert I is equal to 3, 4 is not 3, and so your program would abort and say, there is a problem, this has failed, I'm going to stop going now. And so similarly, we could have, we're not going to be asserting that I is 3 when we just said I, but more realistically, we'll have a function, for example, like doubled, that doubles the number that it's given. So we want to test that when we give the function doubled the number 3, it gives us back the number 6. And so by having many things like this, we can sort of test that the function does what it's meant to do. So the function tells us that it's going to double a number. Does it actually double a number? Yes or no? And so let's do some of that ourselves. I'll make a folder like I did last time. Okay, if that went to plan, you can go to the website, go to lectures, week 4 lecture code. Or not. I was close. Here we go. Cool. And so if you go to the week 4 lecture code thing, click buttons, go to Wednesday live, and then this is the files that I'll be making. Cool. On with the show. Let me just check if this has worked. Awesome. So I'll grab this code. So if we think about our normal programs we have, sure, let's go for this one. I fixed up this code, by the way. So it does actually scan in 500 numbers and then reverse 500 numbers, just in case you're wondering what that code would be like. So this is what our normal program looks like, right? This bit here. In order to do unit tests with assert, we have to also hash include assert.h, just so it knows about asserts. And now, so I've just got some printfs in here. So int I is 3, printf I is the value, which is going to be 3, assert that I is equal to 3, and then print out we've made it. And so hopefully this will mean cool. And so as we had hoped, this program, it's going to be really cool things. Pay attention. It'll be great. So as we hoped, I is equal to 3. We print out I is 3. We've asserted that I is 3, and then we've printed out we've made it. Let me try and fit this one side by side. So let's check what happens if it's not 3. So let's just make a simple thing. Printf, enter a number, scanf into I. Cool. Run my assert program. Enter a number, 3. I is 3, we've made it past. So now if I enter a number that's not 3, like 1, we can see it's crashed on us. It's gone, printed out I as 1, like we'd expected. And then it's tried to assert I is equal to 3. Because 1 is not equal to 3, I'll make this bigger. It said assertion I is equal to 3 is failed. Execution is stopped here in main, so it's on this line here, it's failed, and I was equal to 1. And so when we say like assert I is equal to 3, we mean this must be true. If this is not true, then something bad has happened, and so just quit the program now. Cool. Does that make sense so far? Any questions so far? Yes?
It says values when execution stopped. Is that going to be every variable that you assign a value, or is it going to be the ones pertaining to the condition?
Cool. So that was a good question. DCC has DCC has crashed, and it's told us what the values were when the execution stopped. What values will it show you? Only the relevant-ish ones. Sometimes more than are relevant, often not all of the ones that are relevant, but it'll show you some of the variables. It'll definitely show you I in this case. It may not show you other things. I'm sure I've mentioned before that DCC is like a nice, it's like training wheels for writing code. And when you compile with DCC, if things go wrong, it'll tell you what's going on. GCC, G not D, is a common thing to use outside of this course. And so when things go wrong here, we just get like, assertion failed, this is wrong, aborted. It doesn't tell us what line, or it doesn't show us the line, doesn't tell us the values of the things. So if you're using GCC on your own computer, you'll get less useful information. If you're only ever using DCC, then when you go to future courses, things will break and it'll be hard and you won't know why. So play around with both. But I'll compile that again with DCC. Okay, so I'll save this as assert basic. So now let's do an assert on this doubled function that we made, or that we had from before. Sure, let's get rid of all of this stuff for now. So let's write a function called doubled that hopefully doubles a number. Okay, so does this function make sense? We can have our return like all in just the one line if we want to, or we can have multiple lines of code. But this is saying, when we call the doubled function, take in a number called num, and return num times 2. And so hopefully this means that when we have this assert here, it's going to say that doubled 3 is equal to 6. Does that make sense so far? What's that? I forgot a function prototype again. Oh man, I'd never forget a function prototype. It's one of my biggest weaknesses in life. I forget my prototypes. There we go. So remember, when we have a function, we need to tell it that the function exists. We do that by just copying it, making a semicolon. Life is good. Cool. And so now when we run our assert doubled program, nothing's happened. Like, should nothing have happened? Is it bad that nothing happened? Is it good? Why did nothing happen? I'm hearing some sort of like whispers. I'm seeing some air quotes from a tutor. Did nothing at all happen, or did we just not get any output? So we didn't get any output. We can't tell if anything happened, but we can hope that this means our code did actually call this function and then got the value. So because this is valid, because 3 doubled is actually 6, nothing's happened. It hasn't crashed or anything, but there's no prints in our code, so it doesn't print anything out. But if I change that to be something wrong, so like if doubled 4 is equal to 6, and then I run it and compile it, there we go. So now it has printed something out. It's printed out, everything is terrible and bad. I'll run that again. So assertion doubled 4 equals 6 has failed. So in this case, there are no variables. It hasn't told us about any variables. Cool. Hopefully this makes sense so far. So there's a thing that we do, like when our code doesn't fail assertions and just gives us no output, that's really boring. So we normally do something like this. I'll put that back. What am I doing? That goes down here. So I'm going to make myself a function called run unit tests and just put the unit tests in there. And it's fairly common to have all your tests in a different function so that they're not clogging up your main function. Okay, and so the main function, its job is just to run the unit tests right now. Something worth noting, I don't know if I've talked about this explicitly, when we have our function, this is a void function, it returns nothing, it's called run unit test, it takes no input. The void here is a type, it's saying it takes no input. We don't have the word void in here as well, because that would be like saying run unit tests int, right? It's not a useful thing to say, so we just give it no arguments. Cool, and so again, nothing is going to happen, because it's just calling a function that still prints nothing out. To prove that, I will compile it again. Nothing has happened. So what we normally do when we have unit tests is, at the end of our unit test function, so that we know it's done stuff and that it succeeded, have this thing called printf, all tests passed, you are awesome. And so now what will happen, it's going to run through all of our tests. If the tests fail, it'll quit and say, tests failed, aborted. It won't keep going. But if all of our tests pass, it'll print out at the end, all tests passed, you are awesome. And so we can see that the tests have all passed. I'll add another test that doesn't pass, just to prove the point. If we double 3, it is not equal to 7. And so I'll make that full screen. Even though it's passed the first test, this one was good, it's failed on this one here. And so it hasn't printed out all tests passed, you're awesome, because the tests have not all passed. Very sad. Okay, are there any questions about this? Yes? So was the question, what happens if you call the run unit test thing with variables? Like if you want to use variables?
If your program is pretty complicated, you've got like lots and lots of variables. Should you be testing it just on like values that you put in, or should you be passing your values into the function?
Cool. So the question was, like, if it's a more complicated thing, I think this was the question, should we be testing it just on numbers we've given or on variables? Variables are also definitely a good idea. But the way our run unit tests thing would be all of the tests happen in there. So if we were going to make variables, for example, if we were going to say, get a number, and then assert that doubled I is equal to I times 2. So we'd do the unit test like this. Inside the run unit test function, we do all the stuff we need to do, and then check if that result is right. Let's see if that is indeed correct. To 5. So this one has now failed. This one has thus passed. 5 doubled is equal to 5 times 2. Very good. And then this one here has failed again because it's not valid. Cool. Any other questions? Good question, by the way. Did I answer your question? Cool. Good question. Yes? One of the suspiciously tutorish looking people on the front row has asked, is it a good idea to rely on user input for unit tests? What a good question, mysterious tutor. It's not a good idea to always use things like user input for unit tests. The idea with unit tests is that you test all of these various test cases in your code. So looking for various edge cases like, am I going to get the wrong answer if I check it on the day when daylight savings flips from daylight savings to not daylight savings. And so you want to sort of specify all of these test cases that you want to test and have all those rooted out in here. So for example, we might do something like doubled 5 is 10, doubled 3 is 6, doubled 0 is 0 might be one to test in case somehow it doesn't work. Doubled a million, that might have been a billion, it's equal to 2 billion and so on. And so it's definitely important to have a series of like predetermined cases that you test in your code. Did I answer your question successfully? Is that the answer you were looking for? What's the answer you were looking for? Cool, the tutor has asked a follow-up question. Can I use user input for the unit test in my assignment? No, you can't. Have you not read the assignment spec, man? Should have read the assignment spec. In the assignment spec, we specified that you should not use printf or scanf anywhere. Printf said there, once in shouty letters. Once again here. The one exception to using printf is that when you are debugging, you might need to add calls for printf for your function. So like, for example, if your function doesn't work, you might add a printf like printf the current city is this or the current time is this to see what's happening as you debug. But in your final code, you shouldn't use any printf or any scanf. And so that includes in things like your unit tests. Cool. Have I said the right answer now? Okay, the tutor is happy. Are there any more questions? If not, let's take a 10-minute break. As I have said, every other break, don't just sit down, stand up and do some stuff. Move around a bit. Okay, so moving on now, or sort of taking a step aside, and thinking about functions. So I had, I think, 5 people ask me the exact same question after the lecture. And the question sort of boiled down to, like, when I pass something into the function, like, does the name matter? How does it work? How does the number work? All that sort of thing. So thinking back to when we first learned about functions, we learned functions can have 0 or more parameters. So the things we pass into the function as input, 0 or more, like 0 if it's void, more if it's not void. And a function can return only 0 or 1 values. So either we have a return, like one thing that gets returned, or we have a void function. But then something that we might not have talked about much, when we call a function, it's actually sort of giving it a copy of the values that are inside those variables. So, for example, if I have something, which I'll just put down here for the moment. Actually, no, I'll make anything. Function.c. That was a terrible comment. So if I have a very basic, silly function that just prints out a number. So I pass it in a number, and it prints out that number, and that's all that it does. So if I call print number on 5, what this function will do is print out 10. Sorry, print out the number, not the number doubled, print out 5. So hopefully this is all good and not confusing, because this is all stuff that we've already talked about. Function.c. Oh man, I forgot a function prototype again. I do this all the time, even in my own code that I write, so it's cool. We ran our program, it printed out 5. Let's put a new line in there. This all has a purpose, trust me. I am getting to a point very soon. Okay, cool. So our function, we run our program, it prints out 5. Shh. Our program prints out 5. And the way that our program works is we call the print number function, giving it 5. And so what happens when we do this is we're saying, hey, print number function, here's the number 5. Like, number 5 is the input that you should use. And we can do a similar thing here. If I have int a equals 5, and I pass an a, I will copy the line down there. These do exactly the same thing. Like, they will both print out the number 5, but also the function gets exactly the same input. When we call print number with a, it doesn't give it a, it gives it the value inside a. So when we have this function call, it gets the number 5 as input. So it doesn't get like the variable a itself, it gets the value 5. And so because of this, the order of the parameters is what matters, not the names of them. Let's make our print number thing print out both numbers, I guess. Num1 is this, num2 is this. What have I almost forgotten to do? Change my prototype. Didn't forget that time. Cool, and so now this print number function here, we've just changed it. It takes in 2 numbers rather than 1, and so it prints out num1 and num2. So when I call it like this, I have got int a is 5, int b is 5. So I've got a box in memory that's got the number 5, a box that's got the number 10, and then I call this function giving it the numbers 5 and 10, not giving it like a and b themselves. And then this will print out num1 is 5, and num2 is 10. Hopefully. Cool. Does this make sense? Do you understand the distinction I'm trying to make? It gives it the value that's inside the variable, not the actual variable itself. And so for this reason, it's the order that matters, not the names. Like when we call this function here, it's going to give it 5 and 10. So if we called these num1 and num2, and if we pass them in reverse order, right? So we're passing it in 10 and 5. I'll call those num1. So when we call this, we're giving it the variable num2 and the variable num1, and they've got the same names here, but backwards names. But again, this will give it the number 10 and the number 5, rather than anything to do with the variable names. And I'll run it again. And we can see we've passed it in num2, which is 10, and num1, which is 5. It's printed out 10 and 5. Does that make sense? Are there any questions about that? Cool. So I think your question was, do the names in here have to correspond to the names in here? Was that the question? So the only thing that matters here is that the types are the same. We could actually do this really bad thing that please don't ever do. We could just say int, comma, int. There are going to be 2 ints. It still works. It still runs just fine. The function prototype is just telling it this is what the function will look like. It returns a void. It takes in 2 ints. Don't do this. This is bad. Like print number, it's kind of meaningless. But if we had some function where the variables actually had meaning, like this variable and this variable do very different things, by giving them the name here, it's clear to the person reading the code what this function will do with them. But it doesn't matter what these are called, and these are called, and these are called. We have to use these names here. But this is all unrelated to what this is called and this is called. Did that answer your question? Cool. Any other questions? Am I not using a return because? Cool. So I think the question was, am I not using a return because it is a void function? Yes. So void functions don't return, and we prefer to just not have a return statement at all. Cool, good question. Any other questions? Okay. And so like I said, this is a very important distinction to make. It's the contents that are inside that variable that get passed in, not the variable itself. And so similarly, if I change the thing in here, like if I said num1 equals 100, doing this isn't going to affect anything out here, because I've been passed in here, this has given me the number 10, and changing 10 to 100 doesn't change what happens out here. Okay, cool. So that is a thing that I wanted to say, and now I've said it, and hopefully that's good. And so yeah, the function stores a local copy of the values passed to it, so it has its own copy of the numbers 5 and 10. The original ones remain unaltered. And then an important thing to realize, parameters received by the function and variables made in the function are all discarded when the function returns. So what I mean by that is, if I had something in here like int the best variable ever equals 100, at the end of this function, when we've finished this function, this no longer exists. So I can't refer to this in another function, or it won't exist for any amount of time or anything. Like this, when the function ends, this is gone. This no longer exists. Cool, and then like I said, the names don't matter, the order is the thing that matters. Okay, and so next up is playing around some more with arrays. So I'm going to sort of combine like 3 things. I'm going to combine arrays and functions and unit tests all in one. It's going to be great. I'll open this one. So I'm going to write a program. It's going to scan in some numbers from the user, and then it's going to print out what the smallest number that it scanned in was. So like print smallest number scanned in. Is it the 21st now? Yes. And so my goal here is like the user enters some numbers, and then once they're finished, print out the smallest number. We wrote something similar to this the other day with just using a loop, so we didn't have an array to store things. But in this case, I want to sort of separate out scanning into the array and then doing the check in another function. And so let's have an array. I could make this be 5, but what's a better thing to do than to call it 5? What's a better thing to do in here? Yes, someone said array size, and what you clearly meant was hash define a thing called array size to mean the number 5. Cool, perfect answer. And so what this does is this means that an array called numbers is going to be array size big, which is 5, but if we change the size later on, we just change it in one place. Cool. Printf. Enter this many numbers. Ooh. And I'll even print it out there, so tell the user to enter this many numbers. If I want to scan in lots of numbers, I'm doing something multiple times, and so I need a loop. Yes, thank you, someone. And so loops have 4 parts. There's this one here, this one here, this one here. Cool. What do I need to have in here? Int I equals, someone said 1. I'm going to have it be 0 just because conventionally we have it be 0, especially because arrays start from 0. What do I want to have in here? What does this bit here do? Yeah, it's the condition for when the loop should stop. Is that what you said? I heard the word stop a couple of times. Cool, so when do we want to stop? If we want to scan in array size numbers into the array, so 5 numbers into the array, we want to scan in a number 5 times, so when do we want to stop? Can I slow down a tiny bit? I will try very hard. I'm sorry, thank you for saying that. Do you know why? It's because my talk slowly sign is hidden behind my laptop. Hold it here. So let me try and say that again, but more slowly. Right, so looking at the components of our while loop. Every while loop, and tell me if I'm still talking too fast, every while loop has 4 parts to it. There's this part, this part, this part, and this part. So the thing at the start is like the initialization, so that's setting up something for our loop to happen. So in this case, because we're going to go through some number of things, we're going to want to count the number of things that we're going, like the thing that we're up to as we go through the things. I said thing there a lot of times. Hopefully it made sense. And so because I want to go through, I want to scan in array size numbers, so I want to scan in 5 numbers. If I want to do something 5 times, like what's my condition going to be in here? How do I know when I've done something 5 times? I heard I is less than something. I is less than array size. Is that what you said? Person who I couldn't quite hear. Cool. And so what this means here is this means that while this is true, like as long as this is true, it will keep on doing whatever's in the array. And so I starts out at 0, array size starts out at 5, or is 5. And so this is going to do something for as long as I is less than 5. What do we need to have at the end of our loop? I++. What does I++ mean? Lots of people said things at the same time. Someone say it again and slightly louder. Yes, I is I+1. Why do we do I is I+1? Cool, so summarizing what I think you said, we increase I each time so that as we go around, we're doing things until it becomes equal to array size, and then we stop. Is that what you said? Cool. Awesome, and so this is our initialization, this is our condition. By the way, like you'll never be tested on these words. I'm not gonna make you memorize what these mean, but it's useful to know the language so that you can communicate about this. So, all good. Shh. Don't communicate now about it, communicate later on about it. So this one here, initializing, setting up the thing for our loop. This one here is the condition, so the loop will happen as long as this is true. At the bottom we have the thing that will get us to go to the next iteration of the loop. And then in the middle we have the things that we actually do in our loop. So what did we want to do in this loop originally? Thinking back, we wanted to fill in our array with numbers. So if I want to put something into the current element, like current array element array slot that I'm up to, what would I use for that? Like if I wanted to fill it in, I could say numbers 0 equals 1, numbers 1 equals 100, numbers 2 equals 20, numbers 3 equals 5. So I can set the values of the array like one by one like this, right? I can go in numbers 0, put this number here. In numbers 1, so like the slot number 1, the second slot, put this number. In numbers 2, put this number here, and so on. But rather than writing them all out like this, what can I use in my loop to refer to this? Yep, I can use I. And so I is going to start out at 0, and when I is 0, it's going to be looking at number 0. Then I'm going to go I++, I is going to be 1, and then it's going to be looking at numbers 1. So we can see it's doing this step here. I++, I is going to be 2. Then this one here is looking at numbers 2, which is like this one here, and so on. And then when I is equal to 5, 5 is not less than 5, and so it will stop. So how do I get something into my numbers array? Scanf. Yes, whenever you want to get input from the user, you use scanf. And so this syntax here, it's literally the same as any other. It's scanning into any other int. Like if I had int blah, then I'd scanf into numbers blah, into blah. Right, this is exactly the same, but instead of the int being called blah, the int is part of this numbers array at position I. Hopefully that makes sense. Okay, so I scan in a number, and then I go I++. Cool. Printf, stop entering numbers. Now, just that we know that we're finished. Like that. Delete all that stuff and return 0. So looking at our program so far, and this is a thing that I highly recommend when you're coding, do a little bit of coding, like sort of the minimum thing that will do something, and then compile it and run that and see if that works. And then do the next thing, compile that, run that, see if that works, and so on. So in this case, I've written code to scan numbers into the array. I'll delete that bit there. And so hopefully this will compile. If this doesn't compile, then I know that I've got a mistake somewhere in here. Hopefully it'll work. We won't know if it works because we're not looking at the values, but we can do that in a minute. Min function.c. These names don't have to be the same, by the way. You don't have to call this the same as the C file. I made a typo there. I fixed the typo here. We just do that so that we know which thing is referring to which thing. Okay, it compiles. That is good. Life is good. We run min function. Enter 5 numbers. 5 numbers. Maybe not. What's happened here? I've typed in something that's not what it expects. And so it's sad. And it's just told me to stop entering numbers. How could I have detected that this has happened and done something about it? Do you remember how to find out if scanf has scanned something in successfully? Yeah, heard a couple of people say things like assign it to a variable. So remember, scanf is a function, just like any other function, except it's very long and complicated, and someone else wrote it for us. But scanf returns something, and it specifically returns the number of things that successfully were scanned in. So I will say int num succeeded equals scanf, blah, blah, blah. And then I can say something like if num succeeded does not equal 1. So if we didn't get one thing, which we expected from our one number, then we can go printf, oh no. And then our loop will just continue. In this sort of case, we probably should do something about it. Like we shouldn't just say, oh no, we should somehow get another number or something. But for now, let's just do this. /min function to 5 numbers, 5 numbers. Oh no, oh no, oh no, oh no, oh no. That's very sad. At least we know that we did something wrong. If I enter 5 actual numbers, cool. Didn't scream at me that time. Okay, so I know that my code compiles, and I know that it doesn't crash in the process of entering 5 numbers. But how do I know if it's actually entered the numbers correctly? What do I need to do now to be able to see whether I've successfully got the things that I want to have? Someone said printf, yes. In more broad terms, I want to print out what's inside the array. And so, oh, right, I was going to say there's no closed squiggle bracket. How did this compile? But it's scrolled across. That would be why. So, you know me, I like functions. I like to have functions instead of doing things all on the main function. So let's make a function. It's going to print the array. So when we're making functions, we have things to fill in. What's this thing here inside the circle brackets? When we call a function? Yeah, the parameters, the input to the function. What input do we want to have this function? If this function is going to print out our array, what does it need to have? Let me try that slower. If our function is going to print out our array, what do we need to give the function? The array. Very good. Do you remember how to pass in arrays from last time? To pass in any variable, like if we wanted to pass in, ignore that for now. If we wanted to pass in an int called I, we would literally have int I in here. So we're telling it literally, this is the type of thing that we want to have. In this case, we want to give it our array, which is of type int array and of size array size. So putting this in here, we're telling it, hey, I'm going to give you an array. It's going to hold ints. It's going to be, array size big, so 5 big in this case. What should this return? If our function is printing out the array, should it return anything? No, not really. There's no point. Like, we're printing it out, but we're not doing a calculation or anything. Cool. If I want to do something multiple times, in this case, print out an array element multiple times, what do I need? A loop. Thank you, one person who answered. Conveniently, I have a loop that I prepared earlier here, so let's just reuse that. Let's get rid of that. Okay, so rather than scanf numbers I want to printf numbers I. So remember the difference between printf and scanf? Printf is called printf, not scanf. And printf doesn't have the ampersand here, and scanf is called scanf, not printf, and does have the ampersand here. Scanf is putting it into the number, and printf is just printing out what's in there. Cool. What have I forgotten to do inside my function? I've also forgotten the prototype, but what's wrong inside my function? What am I missing from my loop? I've got this bit, that's 1, 2, 3. I'm missing the 4th bit. Yes, int I equals 0, so initializing it. If I didn't initialize it, then it's going to go, what is I? I doesn't exist. I'm confused. Cool. What else have I forgotten? The function prototype. Very good. You can probably just say that every time I write a function. Oh, you forgot the function prototype. It's probably going to be true. OK, and finally, I want to actually call my function. How do I call my function? What are sort of the things I need? There's 2 bits here. What's the first bit? Cool, the name of the function, which was print array. And what's the next thing I need to give it? Yeah, the input that I'm giving it, which in this case is the array. Shh, I have a very important thing to say right now. So when we're passing something into a function, do we give it the type or just the name? We just give it the name, right? This is something I find, slowing down, I find people get quite confused about this. And so I try to tell them, just think of printf. So when I'm printing out a number, if I'm doing printf I don't printf int I printf I. Like, you've written a lot of printfs, hopefully. So whenever we call printf, which is a function, we just give it the name of the variable. So similarly, to call this one here, we just give it the name, which in this case is numbers, the name of the array. Does that make sense? Cool. Very important thing. If you're going to stop paying attention, you can stop paying attention again, I guess. Min function, enter 5 numbers, 1, 2, 3, 4, 5. Stop entering numbers now, and it's printed out, 1, 2, 3, 4, 5. That's not really useful because I can't tell the difference between that and like that. That's not really what I wanted to happen. I wonder why that happened. Maybe you should go home and think about it. I'll save this as think about this. I'll paste it in there. And I'll actually have no reason to not go home and think about it. Why did this? Oh, what? I tried caps locks. Why did this happen? There you go. Challenge for you. This one. Cool, anyway, what was I doing? All right, I was gonna say, this is not useful, they're squished together, so let's put some new lines in there. I like new lines are great. I have caps lock on, which is why that happened. New line, save, recompile, rerun. 1, 2, 3, 4, 5. Cool. You'll notice that it doesn't actually matter whether I enter them like this, or whether I enter them on one line like this. Wonder why that is? Maybe you should go work it out. But, okay, we've established that we have a program. It reads in numbers. It prints out the numbers. It looks like we've written the right numbers, like we've scanned in the right things. I'll try some numbers to prove it. So 3, 6, 3, cool, matches. It's ignored the 6th one because we said 5, and it's just like, I wanted 5, not 6, go away. So we have established that our program will get the input we want, and we've printed it out to make sure that it does get the input we want. Now that we've done all of this, let's actually do the thing we were trying to do. So if you think back to a while ago, once the users enter the numbers, print out the smallest number that they entered. So, how do I find the smallest number in an array? I'll give you an easier thing. Here is my array. 1, I'm going to put lines 1, 2, what's the biggest number in my array? Sorry, what's the smallest number in my array? 0. How do you know that? Because you looked at it and you saw it was 0, right? But computers can't just look at all of this all at once. Computers can't go, I see 0 is the smallest number. Computers have to do things one step at a time, one single thing at a time. So if you were a computer, you'd have to do, look at this one, 2. Okay, 2 is pretty small. 9, 9's not smaller than 2. 1, 2, 3, it's not smaller. 0, 0 is smaller than 2. 5, it's not smaller. 0 is the smallest one so far. Does that process make sense? Are there any questions? Cool. So let's write a function. Our function finds the smallest thing in the array. Find smallest. It's going to take in the array. So that's all the same. What should our function return? What return type should it have? Like, what's it? Okay. What should it return? What's it going to give us back? Yeah, an int. It's going to give us back the smallest thing, so it's going to give us back an int. Excellent. Okay, find the smallest thing. And so if we want to look through all of the array elements, we have to do something multiple times, which means we need a loop. Yeah, you're getting good at this. Let's steal the loop from before again, because we have a loop, it's great. Okay, but this is just going to print it out. We don't want to print it out, we want to find the smallest thing. Shh. So how do I go about finding the smallest thing? If all I can do is look at things one at a time, what do I need to know, like what do I need to keep track of in order to find the smallest thing? Have a think about it. I want to find the smallest thing in the array, and I can look at one thing at a time. So I need to remember something as I go along. What do I need to remember? Yeah, the smallest thing we've seen so far. And smallest. Cool, and so I'll start out with my smallest. I'll look at this, smallest is 2. Look at this, 9 is not smaller than the smallest, so we can just move on and so on. 0 is going to be smaller, so that's the smallest one, and so on. Okay, so we have a variable to hold this information. How do we store the information? Or I guess the question before that, what should this start out as? What should the initial value of this be? Someone suggested the first thing in the array. Let's go with that. And then we'll think about why in a minute. So we'll start out by saying the smallest is the first thing in the array. While I is less than the array size, so go through everything in the array until we hit the end. How do I see if a number is smaller than another number? And if something? How do I see if something is smaller than another number or less than another number? It's a hint. See if the number is less than, so like A is less than B. Yes, cool. So what do I want to check here? If what is less than what? Thinking back to like the process that we'd go through. We're looking at 2. We haven't seen any other numbers, so 2 is the smallest one so far. We're looking at 9. Is 9 smaller than 2? No, it's not, so we move on. So how do we do that check? How do we check is 9 smaller than 2? Yeah, if numbers I, I'll copy this down here. So numbers I will be the one that we're currently looking at, whichever one we're currently up to. So if the one we're currently looking at is less than the smallest so far, we need to like update that we've found another smaller one, or the smallest one so far is a smaller one, if that makes sense. That didn't make any sense, I'm sorry. I'll try again. So when we find the number 0, for example, 0 is smaller than the smallest one we know about so far, and so we need to update the smallest one we know about so far to be this smaller value, right? And so hopefully that makes sense for this to be this. Cool. So does this make sense? Does the logic here make sense? Is anyone extremely confused? A couple of people. Is there a question that you could ask that would make you be less confused if I answered it? If there is, ask away. If there's not, I'll just keep going and hopefully you're less confused. Yes? So go through like the whole loop one more time. Cool, yes I can. First of all, standing up for 2 hours is really quite difficult. My legs are sore. Okay, so running through this again, running through the whole thing again one more time. So our function is called find smallest, and so in theory, this means that it will give us the smallest thing in the array, or so we hope. It takes in the array. So we start out by saying, because computers can't work it all out at once, computers can't look at this and go 0 is the smallest. All they can do is look at one thing and compare one thing to another thing. Like we can have an if statement like, if A is less than B. We can't have an if statement like if A is less than B, less than C, less than D, less than, like we've got to chain all the ands together, right? So computers can only compare 2 things at a time. Is this less than this, yes or no? And so if we're being a computer doing this, we're going to look at 2. We'll start out with 2 because it's the first element, and thus it's the smallest element we've seen so far, because before that we hadn't seen any elements. An element, by the way, is like a thing in the array. We'd call them elements or members, like array elements, array members, array values. We have all of these different words to mean the same thing, just to be confusing. So if I ever use a word that you don't understand, please let me know you're confused. I'll tell you what I mean. Okay, so we start out, because this is the first value, it's going to be the smallest value that we know about so far, because it's the only one we know about so far. But then we look at 9 and we go, is this next value smaller than the smallest one so far? No, it's not, so we'll just move on. Is this next value smaller than the smallest one so far? No, it's not, move on. Is this value smaller than the smallest one so far? Yes, it is. 0 is smaller than 2. So the smallest one we've found so far, thus, is 0. And then is 5 smaller than the smallest one so far? No, it's not. And so the code for this looks like the while loop is the bit that steps through every array element. And this here is us, this one here is us asking the question, is this one here smaller than the smallest one we've seen before this point? And if it is, then update our smallest, because the smallest one we've seen so far is now this new smaller value. Did that make sense? Yes? No? Still confused? Hopefully that helped make sense. Cool, and so what is the thing I've forgotten to do at the end of my function? Yes, I've forgotten to return something. Given that my function is finding the smallest value, what am I going to return? What do I want to return at the end of the function? Yeah, the smallest value, smallest. Cool. What have I forgotten? Function prototype. Didn't even have to think if I'd forgotten it, I just always forgotten it. Okay, so looking through this again as a whole, we have our array called numbers. We scan in the numbers. We print out the numbers. And then let's call our find smallest function. And so again, when we call a function, we just give it the name of the thing we want it to have. So we don't pass in int numbers square brackets. We just say, the thing is called numbers, here you go. Yes. Can I talk slower? I'm sorry, I'm trying. I'll keep trying. If I block my screen with talk slower, then I will be forced to talk slower. Did I say all of that too fast? Should I go back to... Sorry, the screen just went blank. What? Oh man. Well, I'm definitely going to have to talk slowly now. Okay. I'll just look at this. Talk slowly. Okay, so which bit was I up to before I got distracted by the screen turning off? Was this stuff here so far good? Person who was confused? Cool? Cool. Shh. Do you know what happened? I bumped the power button with my laptop until the screen turned off. Thank you, tutor. Anyway, so we scan in numbers into the array. We print out the array, and we print it out by passing it, we give it the name of the thing to, like the name of the parameter, the name of the variable to take in. We don't give it the type. Like we don't printf, int I, right? When we have printf, we don't give it the type, just the name. This is exactly the same. And so we're telling it, here is our numbers array. And so in the print array function, we've given it the numbers array here, and so it then goes through, prints it out, just like the scanf, but printing, not scanning. And then after that, we call our find smallest function, again giving it the array. And this one here goes through the array. It keeps track of the smallest one it's found so far. And then as it looks at each element in the array, if it finds one that's smaller than the smallest one so far, that becomes its new smallest so far. And then it returns the smallest value at the end. And so this is going to give us a result. I'll store it in a variable, and then I'll print it out. Printf, the smallest number was smallest. Cool. Clear DCC /min function. So enter 5 numbers. Shh. How about I use these ones from before? 2, 9, 1, 2, 3, 0, 5. Is it going to print 0? Do we want it to print 0? Will it actually print 0? Yes. So we've typed in these numbers, it's printed out these numbers, and it's printed out the smallest number was 0. Go computer, you did the thing. Okay. Does this all make sense so far? Sort of, mostly makes sense? Okay, I have 2 things for you. 3 things for you. How would I write a find biggest function? I'll give you a clue. I want to look for the biggest thing, not the smallest thing. If that makes no sense, that's fine. If what I did makes sense, then that's cool. If it doesn't make sense, don't worry. It's fine. But I also want to print out the biggest number. The biggest number was find biggest. And again, I can call my function right in the printf here, rather than making it be in a variable. TCC smallest. This is the problem with just copying and pasting code and changing things, is you change things wrong. What have I forgotten? Function prototype. Find biggest. Come on, cool, you can do it. 1, 3, 5, 8, 0. Cool, the smallest number was 0, the biggest number was 8. Awesome. If you are sitting there bored, please write me a function. Shh. If you are sitting there bored, please write me a function that finds the middle number. So the smallest one, the biggest one, and then the one in the middle of them. And if you're still bored after that, try writing one that prints out the smallest number, and then the second smallest, and then the third smallest, and then the biggest. Those are your 2 challenges. And for those of you who want to pay attention, let's do some unit testing. Test min function. I spelled it wrong. Oh well, cool. So, welcome back. Here's the code we just wrote before. What we want to do this time is we want to have some unit tests to make sure that our code does what it should be doing. And so, like I said before, we often make a function called void run unit tests. It takes in nothing, so the input type is void. It's going to do something. I'm not going to forget my prototype. Okay, and do you remember what I had at the very end of my unit tests thing? Because this is going to run through our unit tests, and if they succeed, we won't get any output. So we normally have a printf at the end to say the tests have succeeded. Does anybody remember what it was? All tests passed. You are awesome. You will soon come to love these words. If your code works, you get to see these words. And okay, let's run unit tests. Currently this doesn't run any tests at all, so it'll hopefully just straight away tell us that we're awesome. It's the wrong file name. That was not the button I wanted. Where was I? TCC-O test min function. Test min function.c. Test min function 1, 3, 5, 7, 9. The smallest number was 1, the biggest number was 9. All tests passed, you are awesome. This is not a valid way to have it say all your tests are passed. You can't have no tests and then say your tests will pass. That's like a false sense of happiness, I don't know. So, like I said before, unit tests are when we run some tests on our code to see that, check if our code is doing the right thing. So I'm going to make myself an array. I'm going to call it array1. Array size. I don't know if I've talked about this yet. We can put initial values into the array. We can initialize the array when we create it like this. So for example, this here we'll make array 1 contain the values 1, 2, 3, 4, 5. And to prove it to you, print array 1. Compile, run, enter some numbers. I recompiled it, didn't I? Yes, indeed. I did actually print it out, but I couldn't tell. Here is your array. I'm going to change this new line to a space so that it's printing on one line, because I can, and it'll be nicer. Declare DCC /test min function 1, 2, 3, 4, 5. Let's pick different numbers. Cool, and so we typed in some numbers, it printed out the numbers, it found the minimax of those, and then in our unit test function, it printed out these values in the array. So let's get rid of all of this stuff. Let's have this just run our unit tests and nothing else. I'll check this over here. And old main. Okay, cool. So, beautiful main function here. It just called the run unit tests. And so now it doesn't require any interaction from us, except it does require our code to compile. What's wrong? I can't have dashes and names. I can't have dashes and names. There you go. Very good. You can't have dashes and names because it thinks it's minus and it gets confused. Test min function. Cool, and so now our program with unit tests doesn't take any input from us, it just runs the tests that we've given it. And so this is the way that we want to run unit tests on our program, is we tell it, here are the tests, please run the tests and see what happens. In this case, nothing has happened, right? I'm not actually testing anything. I want to have some asserts. So assert that something is equal to something. So what's one of the functions that I've written that I could test here? Why don't I test my find smallest? So in this array here, what's the smallest number going to be? What's the smallest number? It's not 5, it's 1. Cool, very good. So what we're saying here is we're saying we expect that the find smallest function, when given the input array 1, this one here, will return 1. And if it doesn't return 1, then everything is terrible and bad and the world is broken, and so just quit, panic, that sort of thing. Cool, test. Cool, so it's printed out our array because we wanted it to. The tests have passed, you're awesome, everything is good. And if I put an incorrect value in here, so I'm expecting it to give the wrong answer, we will see it crash. There we go, I'll make that bigger. So we can see, here's the array, but this test has failed, assertion failed, execution stopped here, find smallest of this did not happen, array 1 contained this. We did not get all tests passed, you're awesome, you're not awesome, not all tests passed. Cool, so just to show another example, I can make myself another array called array 2. -5. Let's do that. And then let's assert that find smallest of array 2 is -5. Cool. So just to go through this again, we have made an array. called array1 with these values in it. And so then we have an array that has these values in the slots in order. We have then made a second array called array2. We've given it these things, which says it has these values in this order. And we can see when we've printed it out, it has these values as we expected. We've then said assert that find smallest array2 is equal to -5. So we're saying make various, like this must be true. If this is not true, then it's doing the wrong thing. So assert that this, given this input, gives us this output here. And then when those both succeed, we go all tests passed, you are awesome. We get that in our terminal, all tests passed, you are awesome. We are awesome. Everybody is awesome. Before we go, I have a feedback slide, and I think it's broken. So I didn't actually get the QR code working, or this link, but this link here works. And again, I'll email it out on like Friday, Saturday, so that you don't have to copy this down. Anyway, end of lecture. Okay, farewell everyone.